Hello everyone. Welcome to the session today, Securing Legacy Architecture Applications in Modern Cloud Infrastructure. We are excited to be partnered with Stromasys, the vendor of legacy server architecture emulators based on x86 Linux. My name is Marlon McNeil. I'm with the Yucca Group. I'm the co-founder and chief technology of the Yucca Group based in Albuquerque, New Mexico. We are a Stromasys implementation partner, and it's our pleasure to be working with them today to share some good information with you. We have a background in virtualizing enterprise class workloads, and in our case, our particular area of expertise is virtualizing extended distance real application clusters onto vSphere, and of course that by extension includes modern cloud architecture these days as well. I'm a technical editor for virtualizing Oracle databases on vSphere. It's a VMware Press book about virtualizing Oracle and VMware and all of the goodness that comes from that. Today we want to touch a little bit on the reality of dealing with legacy workloads, because we all have those everywhere, and of course if we weren't concerned about that we wouldn't be here. We want to talk about some of the components that we can migrate directly to modern OSs. Not every legacy app has components that can be migrated directly, but some do, and the more the merrier as far as that goes. Then that leaves the rest of the application that is custom or whatever, for whatever reason, needs to be migrated lock, stock, and barrel in a lift and shift kind of operation to a cloud infrastructure. And the way that we can do that is we can use a Stromasys legacy architecture emulator that's running on x86 Linux. Then we can migrate lots of different kinds of legacy architectures, SPARC, VAX, Alpha, PDP, to name a few. We'll get into that a little bit more as we go on. And then once we have these applications migrated to these legacy emulators, then we can leverage all of the feature set and the benefits of cloud architecture, all the availability benefits, the security benefits, all the other the cost benefits, all the goodness that's there, we can bring to bear on these legacy architectures and applications, and kind of bring them into the 21st century to a degree. So the deal is with legacy workloads is that if an application is still on legacy architecture, there's a reason, and most likely that reason is that that is a business critical application or has some type of proprietary information or process or something that is critical to making our business, wherever that is, go the way it's supposed to. A second reality is that at some point security breaches and hardware failures really are not a question of if, they are a question of when. As hardware becomes older and older, it breaks down more and more frequently. Of course, and then the third challenge, and maybe not all the challenges, but that one of the big ones is how do we address that? How do we mitigate those first issues and migrate those off to something that's more available, more cost-effective, more secure, and we all have to grapple with those issues pretty much all day, every day. And so the things that keep us up as engineers and as executives, right, are first and foremost, I think, in my mind, is security vulnerabilities. And one of the big serious issues with that is data exfiltration. You know, are some bad actors out there, some bad guys, going to wind up with some of our good information and that they want to do bad things with? Of course, then there's just data loss due to hardware failure or whatever that will impair the operation of our business environment. And downtime, even if there is no data loss, we may have to order a part off of eBay or something, right, to get our hardware back up and working. And so downtime is costly. I was reading recently about a glitch caused by legacy hardware on an airline. Cost that airline $82 million to recover from that lapse of availability that was caused by some aging legacy application infrastructure. And of course, then you have the nagging daily things, the instability, all your folks who have legacy skill sets are all retiring, they're off playing with the grandkids out in the woods somewhere, and they're not available to help out when things go haywire. Again, you're ordering spare parts off of eBay and things like that. The cost, the power, the cooling, the space, the support, if you can even get it, is extremely expensive and becoming more so all the time. And so, why does this keep us up at night? Well, hardware failure, as you know, especially in the legacy realm, accounts for a whole lot of downtime. When you lose an ancient hard drive that you have to run around all over the internet trying to find a replacement for, or things of that nature. And this type of downtime is becoming more and more frequent and prevalent and subsequently problematic, right? Here again, we're kind of back to the elephant in the room. The security aspects of this are the biggest problem, because downtime is problematic, but when it comes to the evolved hackers that we have these days who are good at getting into stuff, especially old stuff that hasn't had patches for a long time, that leaves those systems more increasingly vulnerable to security issues and compromises based on problems with security. And as you can see here, the IEEE Spectrum published an article recently detailing this, and there had been billions of dollars spent globally trying to address and recover from security issues that were that had the root cause of some security fault in a legacy architecture system. And that's a really great read sometime if you have a second. Look it up, and I found it quite enlightening. It was pretty interesting. So fortunately for us, all those things that keep us up at night, there is light at the end of the tunnel. And so our modern cloud architecture really addresses almost all of these problems, fortunately. And certainly with the elephant in the room with security, we can bring to bear zero trust architecture. Certainly, modern security tools. One of the ones that tickles me is inline antivirus scanning, so that we can apply antivirus protection to systems that wasn't possible before, which is really fun, I think. And many other tools that provide similar type security functionality that just isn't available in the legacy realm. Lots of automation tools where we can remove or reduce human error. We have all of your cloud infrastructures have APIs, so you can write your own. VMware in any of the VMware solutions or VMware Cloud in AWS has vRealize automation, so you can automate provisioning and security and all of those kinds of things. And then of course there's the GovCloud architectures these days that are designed with security from the ground up. And of course, with availability, you can get your app in a VM, and then you can replicate it globally across a whole bunch of availability zones and things like that. So the chances of you losing availability for more than just a few minutes is dramatically reduced. Then, of course, there's a great set of backup and recovery tools, Veeam, Zerto, about 10 other ones that are really coming on strong that I've just been very impressed with. And they all do a great job in terms of backup, recovery, replication. You can do an instant recovery and have a VM backup and running in under 2 minutes in most cases. that kind of availability, especially for a legacy application, is just unheard of. And so there's all kinds of great opportunities there in modern cloud architecture. You have mainstream skill set of your support engineers is now available. You don't have to rely on someone who got their certifications 35 years ago. And then of course there's access to all of the rich feature set available in every one of the cloud platforms for all kinds of things, for storage and analytics and all sorts of other things that that are really add value. Best of all, no refactoring. So when we migrate these legacy applications, we can do it without refactoring. We can get it in there and we can do it quickly, safely, and inexpensively. And that is just the best news all day right there. If there's one thing you can take away from this, is that you can migrate these applications to cloud infrastructure without refactoring, which is just fabulous. So the workloads that we traditionally deal with that are stuck on the old legacy architecture, right, a lot of times are, for example, the apps that are blessed by, say, a regulatory agency, the FAA or the SEC or, myriad other regulatory agencies. Then you've got applications that were compiled, written custom to solve a certain problem and were compiled, 20, 30, 35 years ago by someone who had a degree in high energy physics at that point, and then they've retired and gone off to wherever, and finding someone with that skill set in solving that particular problem who can refactor this code sometimes is hard to come by, right? So the author is no longer available, and refactoring at that point becomes extremely difficult when you have to basically write some of these apps from the ground up without the original expertise, the subject matter expertise that went into writing them in the first place. Sometimes those old applications used APIs and things that were specific to a really legacy version of an operating system, for example, or they might have been using some legacy hardware to do things like data acquisition, for example. Now, where can these be migrated to? Basically, anywhere that supports x86 Linux. So any of the cloud platforms, the public cloud platforms, just to name a few we have on the slide, but anywhere you can run Linux, you're good to go. On-prem, with VMware ESXi and Microsoft Hyper-V, to name the two really big prevalent ones. But anything, again, that will run x86 Linux is just great. And then you've got your hybrid architectures, for example, VMware Cloud on AWS, or any of the VMware solutions on any of those cloud platforms, basically, will get you where you want to go. And if you need just raw performance, you can run it on Linux on bare metal, and you'll get about a 30% performance improvement over what you can get in a VM. Granted, you lose the cloud feature set, but you'd gain the performance. And so if that's the driving factor, then that is an option available. And sometimes it's necessary and it works very well. So first of all, we start with the components that we can migrate to Linux. And that would be just simply because our background is in Oracle, we make reference to those. So you can do things like Oracle databases, for example. You may have to do an Indian migration from big Indian legacy systems to little Indian Linux systems. But there is a vendor-supported path for that. Also things like Oracle E-Business Suite, Oracle Forms, Java applications, of course, which are written to be portable across platforms under any circumstances. And then there are a ton of other commercial off-the-shelf applications that also have vendor-supported paths to Linux. And any of those we can migrate to Linux, even if they're just a component of one overall app. Then that's one less security hole that we have to address later. And that's really the benefit of being able to migrate any components that can be migrated directly to Linux, because then we have availability of modern updates and security patches that address CVEs and those kinds of things for your operating systems and your applications, and that's great. You can also bring to bear things like antivirus and anti-malware on the newer systems that are designed to deal with modern systems. Leads us to the next question. So what do we do with the other parts, the other components that we can't migrate directly, that do not have a vendor-supported path to Linux? And that's the fun part that we're here to talk about today. Stromasys has developed several architecture emulators for SPARC, VAX, Alpha, PDP, PA-RISC, and those allow you to run your application in anywhere that x86 Linux will run. So any of the cloud architectures out there, which is really nice because they're pretty much cloud architecture agnostic. If you can make Linux run in it, you can make your legacy architecture run on a Stromasys emulator. And in that context, what can be migrated? So you can migrate your complete operating system installations, lock, stock, and barrel. We'll talk about a method to do that here in a minute. You can migrate just pieces of file systems that are specific to your application, directory structures that are specific to your application. Because our background is in Solaris, we're using that as an example. You can migrate UFS root and normal file systems, ZFS root and normal file systems, VXFS file systems as well, and those are just a few. Anything that's basically on Solaris or any of these other operating systems. So, you know, VMS, HPUX, PDP can be migrated across as if they were being migrated to another physical server. And they all have tools to do that with. So that really makes that doable. And of course, with migration methods, this kind of goes without saying, but you can do a backup and restore. You can do file system migrations like we were just talking about before, and all the operating systems come with utilities that are tried and true and tested and mature that are very good at that. You can recover archives, like backup and recovery, for example. And here again, some examples of this based on Solaris, since that's what where our background is. You can use UFS dump to migrate UFS file systems. You can use ZFS file system migration utilities to migrate pieces or entire via ZFS file systems. You can use a flash archive if you need to move the entire operating system, including your IP address and everything else, custom configuration without introducing human error trying to reconfigure it by hand. You can just move the entire operating system lock, stock, and barrel with a flash archive. And there are lots of other utilities in VMS and HPUX and things like of that nature that do the same type of thing. That leads us to the cloud security enhancements that we have. The very first one that I think is probably one of the best is that we can bring all of these security enhancements together at an affordable price for these legacy architecture apps that we only have to buy for just the apps. We can do most of this stuff in physical infrastructure, but that will break most of our budgets if we were to do that. So we could, for example, put a hardware firewall on every single server in the place, but that would be intractable to manage and would kill our budget, right? For example. And so we can get good security and availability at an affordable cost in cloud infrastructure. So that then of course we have things like zero trust architecture where we can apply microsegmentation. We can clone our legacy apps into dev and test environments like we talked about a little earlier. We can do storage encryption. We can do storage replication. We've got modern security tools, inline virus scanning, for example, multi-factor authentication based against modern LDAP architectures like Active Directory, for example. All the automation tools that we can bring to bear are exactly what we need. Automated incident response, those types of things. So in summary, we have the reality of legacy workloads. We live with them. They're here. We got to deal with them. We can migrate some of the pieces, the components of those, directly to Linux. The rest of them, we can do lift and shift migrations onto legacy architecture emulators running on x86 Linux. And we can do that for a bunch of different legacy platforms. And then use the cloud and all of its rich feature set functionality to apply availability and security to all those legacy architectures. So with that, we appreciate you taking time out of your day to come and spend a few moments with us. We'd love to visit with you in the booth. If you have additional questions, please stop by and we'll be happy to answer every question that you have and visit with you about some strategies that you can employ to migrate your legacy applications into your cloud architecture of choice. So please stop by and we'll love to visit with you for a few minutes. Again, thanks for dropping by and we hope you enjoy the remainder of the conference. So have a good day.